Greetings, students and fellow faculty. School of Tomorrow here, Oregon Curriculum Network. During the COVID pandemic, this is August 2020, and I address myself to teachers a lot. I check the box not made for kids, even though my videos are very accessible to like a teenage audience, which is kind of who I am indirectly addressing through teachers, right? Like my Wiki Educator site, and oftentimes in these YouTubes, I'll state I'm kind of aiming for a high school level. But then a wrinkle on that is I look at high school now as something you might do every 10 to 15 years because of the rate of change and because you just don't have time for everything at that level in your first pass. Like high school is a nice 4 years where they kind of keep it easy. But I'm talking about 9th through 12th grade now. We don't all think in the K through 16 rubric. We don't all think in terms of STEM versus path. So I lose a percentage of you just because of my insider shop talk. And it only gets worse, right? Because I keep going deeper into my shop talk. So that's where you decide at some point, I'll give it a chance. Maybe it's interesting to me. So what you're looking at here is Jupyter Lab, and it's about opening Jupyter Notebooks, multiple Jupyter Notebooks in different tabs. There's another web application just called Jupyter Notebook, which is pretty much oriented around one notebook at a time. Or you could just say your browser's tabs play the role of what are here internal tabs in Jupyter Lab. We've looked at this a lot in my channel. And so I'm kind of circling back to tie off some threads. We've been just recently looking at place-based education, going up the Columbia Gorge, encountering not just one dam. I'll talk about the dam sometimes, but of course there's several, and each one has its own story, its own half-life, or do we want to bring some dams down, like actively destroy the dams on the Snake River or something? And it becomes a big computation around fish, trains, barges. Like there are different modes of transport, so we think about modes and stuff. Now here I am on my local drive. Now teachers, this is where I want to talk to you. Here's what you can do during your pandemic sojourn is create a free stash of Jupyter Notebooks on GitHub with YouTube's embedded that talk about the content of those Jupyter Notebooks, which makes them more autonomous. I haven't seen as many people using Jupyter Notebooks with the embedded YouTube feature. And I understand because the GitHub website doesn't show the frame of the YouTube. It'll show the code for it, but you're not looking at the YouTube. So here we are on GitHub, and here's that three-phase power that we're just looking at. Now this goes to Steinmetz and complex numbers. And you might be thinking, I've watched this guy Kirby for a while, and his math never gets really hard, and his computer stuff, like we spend a lot of time in Codesters and kind of like kindergarten it feels like to you. And you're kind of frustrated because you're worried that we're not getting above high school and you're like a college professor. But we can talk teacher to teacher, and what I'm saying is here's a modality, here's a way to spread your reputation as a teacher by doing your own Jupyter Notebooks and embed your own YouTubes and just, use the framework I'm showing you. Because YouTube is free and automatically you're not copyleft exactly, but what is copyleft? How do you just choose to distribute / publish your work? And YouTube is fairly liberal in that you can embed YouTubes in Jupyter Notebooks and they don't just have to be yours. By YouTube license, once it's on YouTube, this embedding in a Jupyter Notebook thing is not that problematic, right? It's a clever way to tie together some technologies. So I'm always citing other people's, not just citing, but embedding my own and other people's YouTubes directly into my Jupyter Notebooks, right? And here's one on phasers, right? Why do I call them that? Well, because not from Star Trek exactly, but from Steinmetz and from let's learn how to think about AC current and stuff. Because you'll remember in the last video, just the last video, we were talking about unforeseen, problems with AC. AC is kind of tricky. Like you don't just shut it down. By the way, I heard this morning on my walk as I walked by the tennis courts something about rolling blackouts in LA. Is that happening? Is it because of everyone's home using the air conditioning? Is that what's going on? Rolling blackouts. We had those in Manila. And think if you had batteries in your house and could go 2 or 3 days, but would you be able to run your air conditioner? See, that's so power heavy, right? That's a big load, air conditioning, as well as heat. Using electricity, 60 cycles or whatever, to run a space heater. That's something feels wrong about doing that, but hey, if it works, right? If you've got that much power. But if you're trying to conserve, gee, where do you get your heat? These kind of questions. And this all divides or feeds into our personal workspace concepts or working pod, or what is the technology of your personal workspace? Because this other side of it here, we're talking to schools again. I'm not talking about voucher to go to the school of your choice so much as a government voucher maybe to just get your workstation up to speed, hardware, right? IKEA. You need a workstation, you need an internet connection, and where's the build out here? If you want people to have equal opportunity according to the Constitution and all that, then let's just say it takes horsepower to learn math. It's not just paper and pencil, because you're going to do art and stuff, and you need a GPU. You need to browse the web. You need to see all the great videos of all the great museums. You need the full bandwidth of a nice state-of-the-art office downtown, whatever a lawyer has in a swanky corner suite. You need that kind of bandwidth. I'm just talking bandwidth. You're not going to read boring legal documents all day. But I'm just saying, in terms of a school, I've got the end user in mind, the student, and there I'm not happy with room-to-room locker, a locker, and even before COVID or any of that. It's like, what is this, right? This cattle car experience. And the teachers in front, they're like, okay, they're entertaining, they've got this. I've been a full-time high school teacher. And it doesn't have to be a bad job, and I'm not saying it shouldn't happen. Like to have an audience while you do real-time stuff. But all I'm saying is let's think hard about the end user and the personal workspace that's necessary to do what I'm doing right here, because the reason I'm showing teachers how to do this is obviously I am suggesting they then pass it on to their students. So if you're a high school teacher and you have no bandwidth and no access to GitHub and all of that, then this all looks like something other people might be into, and that's correct. It's like other people are into this. This is what millions of people do. Use GitHub and make Jupyter Notebooks and all that. It's not that emphasized in sort of your plain vanilla high school curriculum in the United States, because the government public school system was unable to keep pace. The private sector held it back on purpose. It's like, let's keep America stupid so we can exploit. Stupid people are the easiest to exploit, and I'm not talking about born stupid, I'm talking about made stupid. So the school of tomorrow is an attempt to break out and use a lot of American heritage that is denied you if you're going to a pre-Jupyter Notebook school, a computer illiterate school, where you don't even have the power to do this because you don't have the right technology, and the government has no interest in helping you. You've noticed, right? So that's what we're up against. We're up against an old and dying system, but it's always been like that. Like as a next generation and a next generation, you're the one to breathe life into what's given you and make it better, right? So this is what we're scrolling through, and I'm ending here. I'm just saying what you're going to want to do to tie all your curriculum together is do what I call basket weaving, which is really just a metaphor for the process of creating Jupyter Notebooks, which have multiple components, including running Python, right? So in three-phase power here, we're actually doing a little bit of trigonometry, and we're actually drawing we're actually generating, let's see, what is waveform here, right? It's just a classic, some kind of trigonometric sine wave kind of thing, and we're dividing up, we're creating some domain, we're going to feed in and generate as y value the sine curves and so forth. So we're actually doing the math in the sense of writing code that's interactively runnable. And so we're expecting students, we're expecting teachers to also write code. Like in creating your Jupyter Notebook, you are integrating this kind of math, but it might be natural language processing, it might be anthropology, you might be studying Shakespeare, you might not need the math part as much, but you could still use regular expressions to find this, that, and the other in a Shakespeare play, study the Bible, whatever. Like there are infinite permutations here in practice. I'm just saying it's a process that anyone can do. And if you're frustrated with how I do it exactly, because for one thing it's kind of alien, who needs Martian Math? Like the SAT for Martian Math, if you want to know whether your teachers are being influenced by this tradition, listen to whether they ever talk about A, B, T, S, or E modules. These are little slivers, they're tetrahedrons. You can actually, I keep them in a jar here. Like I have S modules in here, pi scaled, right? This exact shape is called an S module, and it has a plane net. And plane nets are a normal thing in geometry. This would be like 4T or E modules, which have the same shape, but you can still talk about relative size compared to a unit sphere. It's still possible, even though you're talking about the same shape, to make differentiation based on size, relative size. And in this case, the T and the E are so close together in terms of size. In an interesting way. It's an interesting story, whether it has any meaning to you or not. In other words, think of it as pure math, and it has no practical applications whatsoever. None. And so what? So we don't study it? That's not true with chess or checkers. You don't study chess in order to become a great general in some real world, in a metaphorical sense, maybe. Like playing chess keeps you smarter, I don't know. But I'm just saying, in mathematics, we don't require that there be a direct application for something to be interesting. And I'm saying you can take these A, B, T, E, S, whatever, those are the modules, and just introduce them for how they're used to build polyhedra in pure Greek Orthodox Neoplatonist space, right? It's like we're just doing Archimedean honeycombs. It's totally abstract, but we're exercising your imagination, which is just like another power that you have. You have the power to lift things. You have the power to imagine things. But you need to school your imagination. That's why people go to art school and stuff. Anyway, rant ended. Please come back for more School of Tomorrow offerings. These are non-linear, so chances are some of the things you hope I'll talk about in the future, I have talked about in the past. And you can dig through those. And that's my final point, is if you do make a bunch of YouTubes like I do, which are all kind of hyperloopy, hypertext, looped together, I call it a hypertune. And I have more formal definitions. Then, how do you collate these YouTubes? Like, you've thrown them all together, but is it really easy to, like, cross-index them? What are you going to do? How are you going to do that? How are you going to help your reader access just the right one? And this was my question when I left off in the last YouTube, which was all about AC/DC current coming from a dam. How do we find my video on Steinmetz, the guy who helped so much with his phasers as an invention, a mathematical model of how to think about AC. And so I had to dig through a lot of YouTubes, right? Like I have hundreds of YouTubes. I don't know how many. Let's check. And so once I found it, it was like, oh wow, that was doing work, that search, trying to find that. I don't want to do history. Let's look at your videos. Okay, so again, I show you this because you are any teacher, right? I'm talking to the teachers here. In case you're a student listening in, I'm talking to the teachers. Make yourself a stash of videos like I've done here, and they're not going to be collated, they're going to be chronological, and you may or may not follow certain threads for a certain time. I do that. But how do you collate them in the end? How do you index them? How do you make them accessible outside of their chronological order for people? And I'm saying that's another good use of your Jupyter Lab, Jupyter Notebook skills, which you are using these COVID days to develop, right? You've had a lot of time now to get good at this. And now you're ready to turn around and face the students and show them, right? And students have different interests, and they're going to create their own repos, right? And decide what topics they want to pursue. And as a group, let's continue to have things that we all pursue together as schools, like fish. We swim together, right? So I'm not saying that school's all coming undone or anything. I'm just saying here's another workflow for those of you who are so virtual already that this isn't that big a difference, right? This is not the huge cultural jump that it would be for some of you. You're like, I could never do this. This is so far from what I can do. It could feel that way. Or to some people, it's like, oh, this is very close to what I've been wanting to do this. This is the kind of thing I've imagined being able to do. I didn't know it was already here and free, and the workflow is already there's a step missing, by the way, which is all this stuff in the command line to operate with Git, right? So you're doing round trips, you're improving your Jupyter Notebooks locally, and then you're Git pushing them to your repo on GitHub, right? So there's a circle going here. There's cloning, there's all these things, right? So that's not that hard to learn, and that's part of high school now. Learning Git is part of high school, and not just computer science. It's like these are skills like reading and writing. This is part of reading and writing, just like HTML. It's not computer science, it's file management. It's sharing your work. It's learning how to use a combination lock to keep your stuff in a locker. In those days, that was a skill you needed in school, operate a combination lock. Well, Git is getting to be like that. Okay, like driving or something. We'll talk again soon. I hope that was useful. And teachers, chin up. We're going to get through this and look at the great things we have to use these days. Let's take advantage. Talk to you soon.